In this session, we'll discuss about polymorphism. Polymorphism refers to the ability of different objects to respond to the same method call or operation in a way that it is appropriate to their type. Here in poly means many forms. Python's dynamic typing and duck typing make it inherently polymorphic. Functions, operators, and even built-in objects like loops exhibit polymorphic behavior. We'll see in detail polymorphism with functions. A single function can work with objects of different types. If you see here in this example, this is add function definition. It takes two arguments a comma b returning a plus b. If you see in print statement, we have three print statements. In first print statement, we are adding two numbers, 100 and 200. These are two integers. Then in second, we are adding two strings. Welcome to Python world. In third, we are adding two lists. 100, 200 is one list, 300, 400 is another list. So if you see all these three having different data types. Okay. So based on the data type, we'll get the result. Here in the first print statement, the result is 100 plus 200 equal to 300. And if you see here, print in the second print statement, welcome to Python world. Next here, this is the result. Okay. We'll run this program in Visual Studio Code. This is the program. I'll remove the comments, save it, run. Yeah, you can see here 300. Welcome to Python world. And the last one is list, which is having list item. Polymorphism enhances flexibility and reusability in code, making it easier to extend and maintain. Another one is polymorphism with operators. We'll see operator overloading. In Python, operators like plus behave polymorphically, performing addition, concatenation, or merging based on the data type. If you see this example, in print statement, we have given 500 plus 400. So that is integer addition. In another print statement, strings like previous example only. Python plus for data science. Only the difference is we are using operator here. So in the first print statement, 500 plus 400 equal to 900 will be printed. Here in the second print statement, Python plus where data science will be printed because it is addition of two strings. That means string concatenation. In the last print statement, we have two lists. These are the values. And here list concatenation will be happened. We'll run this program and check. Save. Run. You can see the first print statement prints 900. The second print statement, this one, Python for data science printed. The third print statement, two lists combined into one single list. This is the one. Now we will see polymorphism in built-in functions. If you see in this example, in print statement, we have instruction length, len. Length is a inbuilt function. Len of welcome. It prints the string length, welcome length. Okay. Then in second print statement, length of list. How many list items are there? It will print list length. In third print statement, we have max of 100, 101, 109. In these three integers, maximum number of integer that will be printed here 109. Okay, again in the last print statement, max of k, a and z. Here also, so maximum will be printed. That means z, maximum in strings. Okay, we'll run this program. Save, run. Yeah, you can see here the first one, string length, we have 7 characters. So that's why string length is 7 for welcome. Then list length, we have 3 list items. So that's why 3. And maximum of these 3 numbers, 109, correct. And maximum of these KAZ. So Z printed here. Polymorphism enables methods in different classes to have the same name while carrying out different tasks. This is made possible through inheritance and interface design. Working alongside other objective-oriented programming principles such as inheritance, which promotes behavior sharing, and encapsulation, which hides internal complexity. It contributes to building modular, flexible, and maintainable application. We'll see one example here. This code showcases polymorphism using a parent class shape and child classes square and rectangle. Parent class shape contains a reference area method returning generic area, acting as a placeholder for derived classes to override. Child class square initializes side via the init constructor, overrides the area method to return the square's area as side star side. Area of the square is side multiplied by side. For that reason, we have written this statement. Then one more child class rectangle initializes length and width via the init constructor. It overrides the area method to return the rectangle's area as length multiplied by width. Here polymorphic behavior, a list of shape objects, square and rectangle is created. A for loop, a list of shape objects, square and rectangle is created. A for loop iterates through the list, calling the area method on each object. The method executed is determined by the object's type, showcasing polymorphism. We'll run this. Here, the result should come as what is the area of the square? We are passing side value as 3, and if you see the area of the square, side multiplied by side. So 3 multiplied by 3, we should get 9. And for rectangle, values are 7 and 8. So this is length, this is width. Here if you see the rectangle, what is the area? Length into width. So 7 into 8, that is 56. We'll run this code and we'll see the result. Save, run. You have seen area equal to 9, area equal to 56. First one is for square and the second one is for rectangle. So other types of polymorphism. Compile time, polymorphism. It's like method overloading and operator overloading, where multiple functions or operators can share the same name but perform different tasks based on the context. Python, which is dynamically typed, compile time polymorphism is not natively supported. Instead, Python uses techniques like dynamic typing and duck typing to achieve similar flexibility. Another one is runtime polymorphism. It occurs when the behavior of a method is determined at runtime based on the type of the object. It is achieved through method overriding. A child class can redefine a method from its parent class to provide its own specific implementation. And if you see inheritance class with polymorphism, inheritance based polymorphism occurs when a subclass overrides a method from its parent class, providing a specific implementation like this one, runtime. This process of re-implementing a method in the child class is known as method overriding. If you see the example, class animal, here in this animal, we have method sound definition. It prints generic sound. For class dog, same method name sound, it return bark. For class cat, same method sound, it return meow. Dog and cat inherited from the parent class animal. Here object is created, animals, dog, cat, animal. For animal in animals, animal dot sound. So for dog, it prints bark. For cat, it prints meow. For animal, it prints generic sound. We'll run this code. We have seen in the previous session the same code. We'll run and we'll see once again. Save, run. Yeah, we have seen bark, meow, and generic sound. That's all for this video.